We're starting a new section 7.3, and I believe this one's called Trigonometric Substitutions. And so when you look at these first couple of examples that we have, you don't see any trig. And so if you just saw this number one with square root of 9 minus x squared over x squared, you might think substitution, you might think integration by parts. And sometimes that may work in ones like this, but the problem here is if you try substitution, you might try u equals 9 minus x squared. You would get du is negative 2x dx. The problem, though, is that first of all, we have an x squared, not an x. That's a problem. And then also the x squared is in the denominator, while the dx, of course, is in the numerator. So that doesn't work. So we're going to use a method called trigonometric substitution. And it seems, once we get to the answer, it seems, how would you ever think to do this? And I don't know. This is one of those that if it was up to me to figure it out, I probably never would have figured it out. But somebody a lot smarter than me figured this out. And so now we're going to learn it together. So up here, I have a table. And so if you're going to need to memorize this table, hopefully you already know these identities over here. We're going to be using these a lot and maybe some others. It depends on the problem. I think in the homework you might need like the double angle formulas. But you're going to need a lot of the trig identities as we go along here. Now, whatever form your problem is in dictates which of these you are going to use. And if you have these memorized, it's pretty easy. Now, it's easy to do the substitution. You encounter some tricky things once you get into the integrating, kind of getting it set up to where you can easily integrate it. You'll see what I mean as we go along. So we're going to look at this integral. So we're in the a squared minus x squared form, square root of a squared minus x squared. So we're going to use this substitution, x equals a sine theta. Of course, so this is a squared, 9 is a squared, so a is going to be 3. So we're going to let our substitution be x equals 3 sine theta. Then we can find dx, which would be 3 cosine theta d theta. Now, these are a little bit different. So we're doing a substitution, but they're a little bit different than the substitution that we did in the first section, in that we're really just doing a straight substitution. So when we did the u substitution before, where we'd have u equals some function of x, and then we'd find du, and then we'd probably have to manipulate the du a little bit to get it to fit. Here, we're using a substitution where x equals something. X is the original variable. We're going to let x equal something, not u equal something, and then write everything in terms of u. So it's a little bit backwards in that way. So just keep that in mind as we go along. Now, again, just a straight substitution. So 9 minus, now x is 3 sine theta, so x squared would be 9 sine squared theta over x squared, which again is 9 sine squared theta. And now this is the part, if you mess up anything on the substitution, this will be it. You might just forget and write d theta, but dx is not d theta. It is 3 cosine theta d theta. So we need to write that in. All right, now it's really just a matter of getting this simplified in a way that hopefully we can integrate it. So let's see what we can do. We can factor out the 9 on top. So square root 9 times 1 minus sine squared theta. And notice now that we have this, and it tells us that we'll need this identity. And so we will use that. 9 sine squared theta. And then still have the 3 cosine theta d theta. I might be a little bit sloppy with using parentheses or not, but should be able to follow along even with that. Okay, so now we can pull the 9 out of the square root, and that becomes 3. We'll write this as square root 1 minus sine squared. We're going to make that substitution. That's cosine squared theta. And then 9 sine squared theta, and then 3 cosine theta d theta. Okay, so now let's see what we got. Square root of cosine squared, of course, those will cancel out, and we'll just have a 3 cosine theta on top, and along with the 3 cosine theta d theta, all over 9 sine squared theta. And so we can probably cancel out all that. 3 times 3 would be 9. That'd cancel with that 9. And so that gives us cosine squared theta d theta over sine squared theta. Then we have cosine squared over sine squared. That gives us cotangent squared. Now, you don't see cotangent squared too often, but we do here. And we haven't done anything wrong. This is just where we ended up. All right, now I don't know if you know the integral of cotangent squared. I certainly do not, but we do know the substitution. So just like this one, we can write cotangent squared theta plus 1 equals cosecant squared theta. So most of the time when you have some relationship between tangent and cotangent, there's a similar relationship between, a relationship between tangent and secant. There is another similar relationship between cotangent and cosecant. So those usually go together like tangent and secant go together. So let's write this. Of course, we can bring the 1 over, and let's write this as cosecant squared theta minus 1 d theta. Now, the antiderivative of cosecant squared, hopefully you do know that one. That one is negative cotangent. And if you don't know that one, that would be one that you've probably learned at the end of Calculus 1, but again, you don't see cotangent too often, so maybe you forget. But the integral of cosecant squared is cotangent, or negative cotangent. And most of the time you'd see d over d theta of cotangent theta is going to be negative cosecant. So now we just have the negatives switched, but there you go. Then minus theta, and we have a plus c. Okay, so now we need to do the back substitution. So now we have this, and that is not helpful immediately with cotangent. So the way we're going to do this back substitution is to draw a triangle. Draw a right triangle, put theta in, either one of these angles, I guess. Now we know that sine theta is x over 3. And we know that sine is the opposite side over the hypotenuse. So that means that that side is x and that side is 3. And then we can use the Pythagorean theorem to get this side, and it will be square root of 9 minus x squared. And you can work that out if you need to. I won't work that out, but it will actually be this place where we're using the substitution. So that will I think that will always work out. But you can use the Pythagorean theorem and no big deal. Okay, so now what will be negative cotangent? Cotangent is adjacent over hypotenuse, adjacent over opposite. So that would be negative square root 9 minus x squared over x. And then theta is going to be arcsine of x over 3. So minus arcsine theta, and then plus our constant. Sorry, not theta. Let's undo that. Not theta. X over 3. Arcsine x over 3 plus c. And there we go. Okay, so you see this is a fairly lengthy process, and none of these are going to be quick. So know that going in, that none of these examples are going to be very quick, but the better you know your trig identities and your integrals of the trig functions and that kind of thing, the easier it will be. It won't be fast by any means, even when you get pretty good at this, but it can be easier, I guess. All right, so let's look at the next one. So we have square root of x squared plus 4. So x squared plus a squared. So let's look up here. So that will be this one. Obviously, it's reversed, but that doesn't matter when you're adding. So we're going to use x equals a times tangent. So we're going to let x equal a. A squared is 4, so a is going to be 2. And then dx is going to be 2 secant squared theta d theta. All right, so now let's make our substitution. Again, just straight substitution. So 1 over x squared is going to be 4 tangent squared theta square root 4 tangent squared theta plus 4. And then d theta, we'll just write that up here. We just have 1, so we'll just write 2 secant squared theta d theta. All right, so now let's simplify, see what we get. We can cancel these, leave a 2 there. So let's write integral secant squared theta d theta tangent squared theta. And then let's factor out the 4. 4 times tangent squared theta plus 1. And again, you can see if you go back up here, the identity we're going to use 1 plus tangent squared equals secant squared. You can see we already have that set up. Now, you don't need to know that you're going to use that one, but I guess know that you'll use an identity, and it'll fall out pretty easily once you do your first substitution. Okay, so let's see what we end up with. So this will pull out as a 2. Let's go ahead and write our secant squared theta d theta, and then we have tangent squared theta. And then this will be the square root of secant squared theta. Now, try not to do, so it might be easy to see that we're going to have a secant on the bottom. I would suggest try not to skip steps when you're doing this, because if you mess up an exponent, that can either make it easy and you get it wrong, or it can make it hard and you can't figure it out at all. So try not to skip steps as we go along. All right, so we have secant squared theta and d theta on top, and then we have 2 tangent squared secant theta. Okay, so secant squared and secant, we're just going to have a secant on top. Secant theta. I lost a 2. Yeah, there should be a 2 there. And then that 2 comes out, so this is a 4, and then this is a 4. I thought I was losing that. Okay. So we have, secant squared over secant, we have secant theta d theta, and then we have 4 tangent squared theta. Okay. Now, it looks like you might be able to do a substitution in terms of secant or tangent. But again, the problem is you have things on the denominator that you can't really get rid of. So if you're going to do a substitution, it have to be u equals tangent theta. But then d would be secant squared. You don't have a secant squared, so that doesn't work. So a little bit difficult to do any substitution here, because the parts just don't fall out right. So whenever you have a secant and tangent where one's in the numerator, one's in the denominator, probably write these in terms of cosine and sine. So this, and you got to be careful. So the secant is going to go in the bottom here. Tangent squared, that's going to be, we could make it, we'll do this slowly. I will follow my own advice and not do too much here. So we move the secant to the bottom, we move the tangent to the top. So that became cotangent squared over cosine. Then we're done with the cosine. Let's just leave that alone. This will be cosine squared over sine squared. Like that. Okay? All right, let's go up here. We have cosine squared over cosine, so that's going to leave a cosine theta on top. And then we have a 4 sine squared theta. So now, hopefully you can see what substitution we can use. We can let u equal sine theta, and we can let du equal cosine theta, d theta. So that gives us a du on top, and then 4u squared on bottom. And if you like, we can rewrite this as 1/4 u to the negative 2 du. Then just integrate like you know how to do. Add 1 to the exponent, divide by the new exponent, so we get negative 1/4 u to the negative 1. And Now do a substitution. Now maybe, actually, maybe we'll leave this as -1/4u. That actually makes it easier. So now u is sine theta, so this becomes -1/4 sine theta plus c, or -1/4 cosecant theta plus c. Now we need to substitute back into x, so we always do that once we get our trig function in there and after we integrate. Always draw your right triangle. Tangent theta is x/2, so opposite over adjacent, and then that gives us x² plus 4. And again, this third side that we find matches the substitution that we originally did, or the form that we were originally looking at, I guess. All right, so now we have cosecant so we have -1/4 cosecant, which is hypotenuse over opposite plus c. And if you like, you can clean this up and write -√x² plus 4 over 4x plus c. And there we go. Okay, let's look at one more. We have x² minus 25. So go back up, and again, keep referring to this until you got it memorized. So x² minus 25, that's going to be this one. So we're going to use x equals 5 secant theta, 5 in this case. So a squared is 25, so a is 5, so x equals 5 secant theta. Then dx would be 5 secant theta tangent theta d theta. All right, so let's make our substitution. Square root x squared, no, we're substituting, so not x². 25 secant squared theta minus 25 all over 5 secant theta tangent theta d theta. All right. So let's keep going. So we can factor out that 25. We have 25 times secant squared theta minus 1. Of course, that is going to be tangent squared theta. We have 5 secant theta tangent theta d theta. We have integral, just leave this top the same. And then square root, well, we can pull out the 5. We'll pull out the 25 as a 5, and then we have tangent squared theta. 5s will cancel. We have secant theta tangent theta over tangent theta d theta. Okay, so now we have the integral of secant theta. Now this is one you might be able to memorize, but if you don't memorize it, you need to be able to figure it out. So figuring this one out is actually not easy. I guess I don't need to write because it's all we got. So there's a little trick here. So the trick involves multiplying the top and bottom by the same thing. Now the same thing is maybe not intuitive. I don't think it's intuitive, but if you can remember the trick, I guess you can remember the integral and not need the trick at all. But trick is to multiply the top and bottom by secant theta plus tangent theta. Okay, so now we have the integral of secant squared theta plus secant theta tangent theta all over secant theta plus tangent theta. Now you may be thinking, how does that help? Well, again, you almost need to know the trick before you can do the trick. It's not, again, one that you're going to just come up with, perhaps. Especially under pressure, if you're timed testing or whatever. All right, so we're going to let u equal secant theta plus tangent theta. And then du equals, derivative of that would be secant theta tangent theta. The derivative of tangent is secant squared theta. So now this numerator just becomes du, and the denominator is just u. So then this becomes ln of u, absolute value, plus c, substitute secant theta plus tangent theta. Now we need to get back to x, so let's draw our triangle. Secant theta is x over 5, so that's hypotenuse over adjacent. And then we get x squared minus 25 square root. Okay? So we end up with ln. Secant theta is x over 5. Tangent theta is opposite over adjacent, so that is square root x squared minus 25 over x. Let's see. Okay. Did I do that right? I did that wrong. Hypotenuse, that should be x. That should be 5. I did do that wrong. Okay. Hypotenuse over adjacent. I did that wrong. All right, so this becomes, that's still x over 5. That one's right, but this one should be 5. Yeah, okay. That was the only place I messed up. Okay. Yeah, so again, you gotta be careful. These are long, a lot of places to make a little mistake, and so you know, carefully do your substitutions and know your trig very well. And I think they should go well for you. Practice them enough, have this table up here memorized. This part is the part that you need to memorize. The identities you probably already know. If you don't, you should. This is the part that you need to memorize. This part right here. So you see this form, you do the substitution. You see this one, you do this one, and so on. Okay. If you need help with these, come to office hours. I'd be glad to help you because some of these are tricky. So I know it takes practice and it can be a little bit frustrating when you're learning. So if you need help, please ask.